Okay, today is what we learned the last part of Chapter 6, which is Le Chatelier's principle. Le Chatelier deals with systems that are at equilibrium, and that's important. They have to be at equilibrium before Le Chatelier's will, guys. Anytime when you're ready. Yes?
What type of equilibrium?
So it has to be at equilibrium. It has to be at the point at which it has the same going forward as it goes backwards. So it has to have reached equilibrium. So when we were talking last time about rates, we started here and then it came down and they were at the point where they had no slope. Where they have no slope, that's equilibrium because the forward and the backward reactions are the same. So Le Chatelier only applies to reactions that are at equilibrium at that point. Okay? We're going to do silver test tube lab. Like I said, I'm going to take you back small groups at a time. While you're in here working, you need to be working on Learn Smarts, on homework, on the lab, getting the lab written up, because when we come back, the first day back, I'm going to be checking off those labs so that you can get into lab the next time. And we're also going to be doing 2 small little labs. One is going to be an equilibrium lab, and one is going to be a calorie lab. Okay, so we're going to do those 2 little mini labs. I'll be checking off your big lab, experiment 11, to get into lab the next time. The next time will be all day lab, so you need to make sure that you and your partner are ready to roll, ready to do what you need to get done.
After the break, right?
Yeah. So that the one we wrote up. So the first time is the calorie lab, the equilibrium lab, and getting your lab checked off. The second day after break is doing your lab. The third day after break, you get half of that day, and then we're going to do a speed dating kind of thing with your review for the next test, and then answer questions, and then test. You got 4 days after the break, that's it. So remember that all your homework, all your Learn Smarts, all your labs are open to be redone, as far as the labs, are able to be redone until January 10th. At January 10th, it's done. So you want to get things submitted so I correct them and back to you, so if you did something wrong, you can fix it. Okay? All right, so here we go. Le Chatelier. Basically, I went the wrong way. Okay, is about sort of like a teeter-totter. Basically, Le Chatelier says, once you're at equilibrium, you're like a teeter-totter that's equal on both sides. If you add a stress to one side or the other, the reaction will act to relieve that stress. Okay? So that's what his principle is. A system that is placed under stress will undergo a change in such a way to relieve that stress. So in other words, if you're standing and you've got a nice stance here and a friend comes and bumps you, you compensate, right? Or you fall on your face. Same thing with Le Chatelier. And we're going to be using that to determine how different things affect reactions.
Which notes are these?
Unit 6, the last of it.
I don't think I got them.
Check and see if there's some in the brown. I don't know if I've got another one. If not, I'll have to print you one. I don't think these are. That's generals. So there's 5. I'm going to have to print you one. It'll print out back in the very back lab. Do that real fast for you. It's thinking about it. Just went into Neverland. Why did it go into Neverland? The whole computer did. Okay, we got that one copied down. Okay, going on to the next one. These are the things that will be affected by Le Chatelier's principle. Okay, go ahead and head back to the back lab and it should be printed. Okay, so concentration change, temperature change, and pressure change. And pressure only works if I have a gas in the system. If I don't have a gas in the system, pressure doesn't affect it. So pressure only affects gases. Temperature, we need to have an endo or exothermic reaction. If they're not endo or exothermic, temperature doesn't affect it. Concentration affects most everything except solids and liquids. So it's sort of like when we wrote our Ks. We don't write the solids or the liquids, but we do write the AQ and the gases. So these are things that can cause stress on an equation. And we're going to take each one of them and look at each one of them. Now, when I was in college, I had a professor that just threw this out. He didn't help us understand it. And I with the study group that I was in, came up with this method I'm going to show you. And it works really well. And I haven't got one problem wrong because of it. So, we okay to move forward? We're going to have to catch you up. Okay, so this is what we did. You write your equation. If you're putting stuff in, you're going to put an arrow above it going down. If you're taking stuff out, you're going to put an arrow below it going down. Okay? That arrow, the point of the arrow, has to cross the double-sided arrow. Okay? So if I'm putting stuff in order for it to cross the double-sided arrow, I've got to sort of curve. I've got to sort of curve and go like this, right? To make it cross that double-sided arrow. That means my reaction is going to shift towards the product. When it shifts towards the product, it takes some oxygen with it and makes more CO2. So my oxygen concentration goes down and my CO2 concentration goes up. Okay? I also think of it, my dad used to have topsoil and like bark delivered, and they would always just dump it in the driveway. And then guess what? We got to move it around. Right? So this is like somebody's dumping stuff right here, and my dad's saying, it's not staying here. We need to distribute it out. Yeah. And then when it's taken out, it's sort of like when you have a dog and they dig a hole, and then your parents go, you get to fill that hole up. So you got to go out and fill it up. You've done that too. So this is what we came up with. Okay, so if you have a concentration change, if I add more product, again, it's got to cross this arrow, so it's got to come that way. Does that make sense? So if I put it in, arrow coming down, that arrow's got to cross. So then I would have more reactant and less product. Okay? And these are just examples. They're not in your notes, so just keep with me up here, and then we'll do the ones in your notes. So what if I remove it? Well, if I remove it, I've got my arrow pointing down here. It can't cross unless the arrow came from back here and then went down. Does that make sense? So because of that, I'm now moving some of this over here. I'm going to have less ethanol. I'll have more, this is ethene. I'll have more ethene, and I'll have more water because I'm trying to fill that hole. Does that make sense? Okay? All right. This one, if I'm increasing pressure, this is where, oh no, this is temperature. When I'm doing temperature, they have to give me delta H. Now, careful. Sometimes delta H is within the equation itself. Sometimes they write it outside it, like this. Remember that positive goes in the reactant side, negative goes on the product side. But you still put it inside the equation as a positive. The positive and negative tells me what side of the reaction it goes on. So that's like putting it over here saying I have 43 kilocalories on this side that's needed to make that reaction go forward. So if I add heat, it's like adding in here, and then that would have to force to go that way to equal it out. Thumbs up, I'm getting this. Thumbs down, I'm not. Thumbs sideways, I'm still, yeah. Okay, we'll still keep working. This is an endothermic because I have to put heat into it. Okay, so we're going to do a whole bunch of these. This is just showing you how it works.
If you go back for like
half a second. Half. Okay, on this one, since this was a negative, we would put it on the reactants or on the product side. So it's like adding it right here. So kilocal. So if I put heat in, it's putting heat on this side, And to cross the arrow, I take that arrow and make it go across. So I would have more reactants and less product. Okay? All right, so let's take it where we go to gases. Now, this is where pressure affects, only when we have gases. We have to look at each side. How many moles do they have? So here is a 1, here's a 3. Adding together, I have 4 moles of gas here. I'm looking at their states. Over here, I just have 2 moles of gas. So, when I apply pressure to something, it's forcing things to go together. Okay? So it's forcing things to combine, forcing elements to become compounds. Increasing the pressure makes that happen. Okay, so this is forming ammonia. In order to form ammonia, I put it under a lot of pressure. It'll force the reaction forward. If I release that pressure, it wants to go backwards. Okay, so there's 2 ways they can say this. I can say increasing the pressure, and it will go to the side with the least amount of moles. Or I can say decreasing the volume. Because if I decrease the volume of something, it also increases the pressure if I haven't changed anything inside. Okay? So if I do the opposite, if I decrease the pressure, that would be like increasing the volume. And if I increase the volume or decrease the pressure, I force it towards the side that has more moles of gas. Okay? All right, so here is what is in your notes. You got colored pencils in front of you. I suggest you use them. On the first one, if I add reactants, that's like adding stuff on this side for both of them. Okay? If I add reactants, which way is it going to force the equation to go? Okay? I'm adding piles here. Dad's getting mad and I got to spread it out, right? I have to cross the arrow. So I'm going to cross the arrow by going like this, right? So I'm going to make more products. So I'm going to go towards the product. And I'll write it out the first couple times and then I'm going to shortcut. Okay? So adding reactions forces us towards the product. If I remove reactants, so here's my arrow going down. Since it's pointing down, I can't go across because I've got to go to the equation. So I have to actually come here and come down this way to make that work. Everybody see that? So because I'm doing that, what's happening? Which way is the reaction going? Well, towards the reactants, right? Okay, on the next one, we're adding products. So I'm going to put in piles on my product. It's got to cross that arrow. So which way is it going to go? Towards the reactants. Good. So it's going to go this way to cross the arrow, right? Okay, so I'm just going to go arrow to reactants. I'm shortcutting already. On the other side, on the next one, it says removing. So I'm going down here. Good. It's got to cross that arrow again. So in order to cross the arrow, it's got to go down towards the product. So towards my products. Okay, we're going to check and do another learn check. I'm getting this better. I'm still not quite sure, or I really don't understand. That's good. Okay, we're doing better. Okay, now we've got an actual equation I've put in there. I have added states. I've added states, and I've added where the heat is. Is this an exo or endothermic reaction? Exo, because my heat is on the product side. They could have also given me the heat as delta H equals a negative 45.8 kilojoules and not given to me in the reaction. Okay? Either way, I need to know where it goes. So, let's look at the temperature increase. Temperature increase. Where do I put my arrow? So if I'm increasing temperature, I'm putting in heat. Right? Now, This might still sound silly, but if you don't put your arrows down, our study group found that 50% of the time we got it wrong. But the minute we started using the arrows and actually drawing them in, we got 100% right. So use the arrows. They might seem silly, and you say, oh, well, I can think of it in my head. Just do the arrows. Okay? Because then I can say, okay, I hit the equation, and I've got to cross the arrow. Right? And that tells me the direction right there. So it is towards my reactants. Now, if my temperature decreases, yeah, because I've got to go through the arrow or through the equation to get to that arrow. Right? So I'm going to go that way towards my products. Everybody okay with that so far? Okay, next one. They could do either one of this. They could say increase pressure, or they could say decrease volume. They don't have to give you both, but they mean the same. Okay, so you got to get it in your head. So what do I need to do for this one? Well, the pressure is going to affect both sides, so that's not going to help me. What do I need to do here? I need to figure out the moles on each side of gases only. So if there's liquid, solids, or aqueous, it doesn't count. Only gases. And that's really hard, so make sure you remember that. So over here, there's a 1 and a 3 giving me 4 moles of gas. Over here, there's a 1 and a 1 giving me 2 moles of gas. So if I am increasing pressure towards the side with the less moles, so it's going to be towards the product. Okay, and if I decrease pressure or increase the volume, towards more moles, right? So towards my reactants. Thumbs up, I get this. Thumbs down, I don't. Thumbs sideways, I'm still confused.
So I'm confused on why when you decrease volume it goes towards the less.
Because when I decrease volume, okay, I have all you guys in the room this size. Now, what happens when I get to a room a fourth this size, but I still have all you guys in the room? Okay, pressure gets a little bit more. Right now you have some space to move around, right? You have your own space, but then we're going to start crossing each other's boundaries and the pressure is going to increase. Okay, so that's what you got to think of. Decrease pressure, increase volume means we get a bigger room. So we have our own tables. We have our own area. Okay? All right, let's keep going forward. I want you to try to do these 6 on your own, and then we'll come back and we'll see if you did them right. So I want you to try and do these 6 on your own. Take a minute, do the arrows, figure them out. When you're done, look up so I know that you're done. And you can use the arrow and just put the R and the P like I did. That's fine. Forgot to change the date today.
I'm still confused on how we how to memorize that when the volume is increased, the pressure is increased, and that goes towards the less.
So if a pressure is increased, I'm squishing things together. And when I squish things together, they combine. Okay? That's when I go to the side that has the least amount of moles of gas.
Because it's starting by.
Right. When I have more volume or less pressure, that's when they go to the side that has the more moles of gas. You just got to memorize, yeah. Or put on your card. Okay. Okay, we ready to start? Give you a few more minutes? Okay. Oh, excuse me. Okay, I'm waiting for everybody's eyeballs to tell me that they're done. Ready to roll here. All right, let's try this first one. CO is added. That means it's going to go that way towards the products, right? H2 is removed. That means I've got to come through the equation to get to it. That means the reaction's going this way. Okay, H2O was added up above. That means I got to go through the reaction that way. That means I'm headed to the reactants. CH4 is removed. I've got to come through the equation this way to get to it, so I'm going that way towards my products. Volume is decreased, therefore pressure increases, okay? 1, 3, 4 moles, 1, 1, 2 moles. If pressure is increased, I'm going that way towards my products, to the side that has the least. Heat is added. I'm adding heat here. To get to my arrow, I've got to go this way, so I'm going towards my reactants. Thumbs up, I got them all. Thumbs sideways, I got some of them, and thumbs down, I didn't get any of them. Okay, those of you that are thumbs sideways, I heard a couple of you, I didn't read it right. Was there anything that you want me to explain that you didn't understand why we got it? Yes, Luke. Heat is added. That is your kilojoules. So when you add heat, that's like putting an arrow down on that side. So I'm making a pile on that side. I got to spread it out away from it. Okay? All right, any others? Okay, how are you feeling about this? Thumbs up, thumbs sideways, thumbs down. Yes?
I need Benjamin Williams to come to the attendant's office to check out.
Okay.
Thank you.
You won't get to do your silver test tube. How sad. Okay, thumbs up, thumbs sideways, thumbs down. I didn't get to see that. Feeling good about this? Yeah. Which way? Okay, I saw some of you. Okay, so we're going to go on really quickly to review catalysts. You need to be able to take one of these activation curves and tell me everything about it. Okay? She will probably give you an activation curve with ABCDs on it and say, what is A? What is B? What is C? So, what is this? Potential energy reactants. Good. What is this? Potential energy of products. What is this?
That's energy reaction. That's difference of energy from the product.
So this is either delta E, you've got to look at the side, or delta H. If it's heat energy, it's delta H.
If it's just normal energy.
Just delta E. Okay, what about the distance between here and here?
That's the chill out energy. That's the energy it takes for the heat to chill out.
Nope.
That's the non-scientific way.
Energy of activation for the reverse reaction.
Yeah, the chill out energy.
Okay, what about this energy? That's the energy of activation for the forward reaction. And if it has numbers on the side, you'd have to give the numbers.
Is it E to or EA to the first or to?
It's prime.
No, it's just
It's EA prime. It's like a, apostrophe, yeah. Okay, what is this area right here?
which area? Sorry, I was
The very top of the curve. That's your activated complex. Okay, so if she asks you where your activated complex is, at the top of the curve. She can also ask you the difference between a catalyzed versus an uncatalyzed reaction for the activation energy. Right, and she could also ask you, I'm going to change colors, the activation energy of the catalyzed one and the reverse reaction energy. Okay, So catalyst, what was another name for catalyst? Fiddler on the roof. Matchmaker. Okay, remember in the video it talked about being a matchmaker here, and I told you about the matchmaker. Energy of activation, what is that? Right, the energy needed for the reaction to go forward. Net energy of the action is what? It's the difference between your reactants and your products. Okay, that's your net. Potential energy is what you have at the time. Okay? All right, so what we're going to do is I'm going to take you back about 4 or 3 at a time to get you started on this. The rest of you are going to be working on your Learn Smarts, on your labs, on whatever needs to be done. Okay? That's all Chapter 6. We're going to review it a little bit when we get back. Yes?
Can we go back first?
Go back to... Oh, go back to lab first. I was like, okay. Let me get this started, and then I'll pull a group back. You'll be second, probably.